Hello and welcome to NumPy Crash Course. So in this tutorial, we want to quickly go through the NumPy library and understand how it works. So NumPy is a Python library which is used for numerical computation and provides efficient functions for working with large arrays and matrices of data. So you can simply import it by saying import NumPy as MP. So you can import it as, you can use any name as you like, but usually we use NumPy as MP and run this. You can see that because this is the first time I'm using this notebook, it is first connecting and then starts running this cell. Right, now the NumPy library is imported. I have a green check mark here. I can create another cell and create my first NumPy array. So we're going to start with creating, working with arrays of data. So the arrays could be 1D, one-dimensional, or two-dimensional. Let's start from one-dimensional. I will call it NP, it's NumPy, and I will put 1 here because I want to create several NumPy arrays. So let's create a one-dimensional NumPy array first. I would say mp.array. So I'm using this MP that I imported here. I imported NumPy as MP. I'm using that and I'm calling array function of NumPy library. And inside of the parentheses, I simply should say inside of the bracket, I simply should define my vector or my array. So I'm saying, for example, 1, 2, 3, 4, 5, 6, I don't know, some random numbers. So if I run this right now, I created my first array and saved it in np1 variable. So I can check the, first of all, the type of this np1, and it should be a NumPy array. You can see NumPy array. And also the dimension of it, as you can see, is 1 because we only have a vector, 1 dimension. But what if we want to create a 2-dimensional array, like matrix, for example? So to do that, I can say, let's call it np2 this time, and I can say mp.array. So inside of the parentheses, this time, because I want to make 2-dimensional, so I need first set of brackets for creating my array, 2-dimensional array, and for each row of that array I need one set of bracket as well. So I'm saying, for example, let's say 1, 2, 3 for the first row, then put comma, another sets of bracket for the second row. Let's put, for example, 4, 5, 6, right? Now you can see I have an array in a matrix format and it's 2-dimensional. This is the first row and this is the second row. So if I, for example, call mp2 again, you can see that we have an array with this format. So this is our first row and this is our second row as we asked. So this is 2-dimensional array. In the previous cell, we created 1-dimensional. We only used one set of brackets. But remember, when you want to create 2-dimensional arrays, you need to put, for each row, you need to put the values inside of a set of brackets. So we can also check the shape of the, for example, mp2 simply by saying print np2.shape. You see it's 2 by 3. What does it mean? It means that it has 2 rows and 3 columns. And as you can see, it's right because we only define 2 rows, first row, second row, and 1, 2, 3 columns. So 2 rows and 3 columns is the shape of the using the shape attribute. We actually check the shape of the matrix, or let's say array that we created. So you can also check the size of the array that you created by saying that print np2.size, run this. It's 6 multiplying 2 by 3. It's the size of the array. That is 6 for this np2 array. And we can also check the dimension of the array as well by saying print np2 dot ndim, run this, and as we can guess, it's two-dimensional array, so it's showing us 2. If I change this to np1, for example, it should show us one-dimensional array. Run this, you can see it's just one-dimensional because it was a vector we defined. So so this one was 2. And this was all about how you can create an array using array function in NumPy library, and also check the dimension of that, size of that, all these things about the array that you created. And the most important part of NumPy library, I think it's actually indexing part, and it's very, very important. So listen to me carefully. So for indexing parts, first of all, let's say, for example, I want to check the first element of MP1 array that I created here. What should I say? I should say MP1, inside of the brackets, I put the location of the elements that I want to check. For example, if I want to check this one, I should put 0 here. So if I print this right now, you don't have to print this in if you're using Google Colab, but I'm using print because some of you may use other IDEs than Colab. So if I run this right now, you can see that it will print out the first element of the NP1 array that we created here. So I can simply define the location of the elements here in my 1D array, and it will print it for us. So we can change this to, for example, 2. It will give us 3 because 0, 1, 2. This will be the location of the 2, so it will be 3. And so on. You can just feel free to try it for yourself for this one-dimensional array. Now, let's say you want to filter a range of value, not just one value. You want a range of value. For example, let's say I want from here, say number 4 and number 5, and put them in a new array. I want these two elements, these two values to be filtered out, and I can save it in another, for example, another variable, or just check that out. So let me create another cell. So what I want to do is saying, okay, let's print that out instead of saving it in another variable. Let's say MP1, and inside of the parentheses, instead of just saying, for example, the location of that, because I want the range of something in this MP1, I want from here to here. So it starts from, let's say this is 0, 1, 2, 3. So you start from 3, put 3 here, and 4 and 5. So Python doesn't consider the last number. So if I say until 5, it doesn't consider 6, so it will stop at 5. So I'm saying 3, 2, 5. All right. So if I run this right now, it will filter out 4 and 5, and it will give me 4 and 5 in a form of array to me. All right. Okay, so what about 2D arrays? So what we discussed for the indexing, it was just for 1D array. Now we want to discuss the 2D arrays. Most of the times we are dealing with 2D arrays. So that's very important to understand how we can understand the indexing part. So for the 2D array, let's say, for example, first of all, let's print it out again. Let's say MP2. Let's see it here. So this is our MP2, right? And now in this MP2, I want to, let's say I want the first element. So I'm simply saying MP2, and inside of the inside of the bracket, I put 0. So you can see that it will give me the first row as an array. So it will, so the first element of this 2D array is actually not 1 here anymore. It's the whole row here. You can see this is the first element. So when you are saying MP2 is just 0, it gives you the whole row. So if you want specific index in that first row, for example, you want 3. You don't want all the numbers in this row. You don't want 1, 2, 3. You just want 3. So to do that, I can simply say MP2, and inside the brackets, I just say 0, comma, 0, comma, and 2. So 0, 1, 2. So if I run this again, you can see it will show me 3. So this means that I want the first row, and inside of the first row, I want the third element, 0, 1, 2. So what if you want, for example, let's do something else. What if you want all the rows, but the values in just first column, 1 and 4, all right? So let's create another cell so to keep all these things that we are doing. So I'm saying MP2, this time inside of this, inside of the bracket, for mentioning that I want all the rows, I'm using colon. Okay, that's for rows. So I want all the rows, put comma, now it's time for columns. So for columns, we only need the first one. What is the index of the first one? It's 0. So if I run this right now, it should give me 1 and 4 only. See, array 1 and 4. So what if, let's do vice versa. What if this time I want all the columns, but I just want the first row, not, I mean 1, 2, and 3. So to do that, I'm mentioning MP2 this time by saying that I want only the first column, first row, comma, and because I want all the columns, I just put colon here, right? Run this, it will give you 1, 2, and 3. So this is exactly same as when we say MP2 0. Similar to this one, MP2 0, it will give you the first row. Let's do another thing. Let's say I want to filter out the second row and second column. I want to filter out the second row, and second column. So to do that, I'm simply saying MP2. I want the second row, so in the row part, I will say 0, 1, comma, and in the row part, I will say 0, 1 again, 1. Write it down, run it, and you can see it will give you the exact number that you're looking for. Second row and second column. All right. What about you want all the rows and all columns? So you can simply say MP2, I want all the rows, comma, all the columns. Write it, run it, and you can see it will it will print out the whole array for you. So I think you understood what's going on here. So for the indexing part, you can simply separate rows and columns with a comma in between, and you can simply say set the range that you want in the row part and also in the column part. You can use the colon sign in order to say that, okay, I want all the columns or all the rows, or even when you want to set a range for that. So for example, let's make it a little bit complex. So let's say, for example, this time I want to get the first and second rows, and also I want to skip the first column and get the second column and third column. So what I want to do is getting these two rows, both rows. Actually, we only have two rows, so both rows. And I want to skip the first column. I want to just filter these two columns, the second and third one. So to do that, I need to define a range in rows and columns area. So it's very simple. What I should do is just saying np2, inside of the brackets, I mention, okay, in the row part, I want from 0 to 2. From 0 to 2. Or even you can mention just all the rows, because we only have two rows. But I'm mentioning it here 0 to 2 because sometimes you're dealing with bigger arrays, so you don't confuse this. So let's say 0 to 2, it's the same thing, comma, and for the column part, I want from 1, because I don't want 0, I want from 1, 2, and if you mention 3, it doesn't read it, so you should say 1, 2, 3. So 1, 2, 3, it means that consider the second and third column and skip the first column. And this tree, if you know the indexing of the Python, it starts from 0 and it doesn't count the last value in your range. So if I run this right now, it will give me the exact thing that we discussed. Skip the first column, keep the second and third column, and also both rows, 2, 3, 5, 6. All right. Let's simply go through some arrays operation and close this tutorial. So for arrays operation, we can simply say, okay, let's define two more arrays. Let's say np3 is equal to np.array. This time I want to create 2D array, but with two values, comma, another sets of bracket, 3 and 4. Right, I just copy this, paste that here, and just change the values to, let's say, 5, 6, 7, and 8. All right. So I created two new arrays, and let's call this one np4. Run this. And now I want to do some calculations. So first of all, let me print out these two arrays for you. So print np2, np3, and print np4. Run this again, so it will print out both arrays for us that we created, 2D arrays with 4 elements each. And now, for example, let's say we want to say np3 plus np4. If I run this right now, it will give me an array like this. So as you can see, it went through both arrays and it added up each element with each element. So it is element-wise summation. 1 plus 5, it gives us 6. 2 plus 6, it gives us 8. 3 plus 7, it gives us 10. And 4 plus 8, it gives us 12. That was element-wise summation. The same thing we have, for example, for subtraction, np3 minus np4. If I run this right now, you can see that it goes element-wise, 1 minus 5, 2 minus 6, 3 minus 4, 4 minus 8, and this will be the final array. Same thing for if you go for dividing them with together, NP4. If I run this, you can see that it's again element wise, elements by elements. And at last, for multiplication, I'm saying MP3 multiplied by MP4. Run this, you can see that again it's element wise. 1 to 5, it's 5, 3 to 7 is 21, and so on. So what if what's the thing is actually the main difference between an array and a matrix is matrix in array, when you are multiplying, the default of the multiplication is element wise, while in matrix, when you are multiplying two matrices together, the default is in a matrix format multiplication. If you want to multiply two arrays with the matrix multiplication format, you need to use @ signs. So I'm saying MP3, I'm using an @ sign in between, and MP4. So instead of the asterisk sign, I should use @ sign. So if I run this right now, you can see that this time it actually multiplied in the matrix multiplication formats. So the first row into the first column. So 1 to 5, 2 to 7, that is 5 plus 17, that is 19, and so on. So that was it we have done a very quick review on what are NumPy arrays and how they works. I hope you learned some basic things about NumPys. Until the next tutorial, keep exercising.